All right, Lady Ada, what is this?
Hi, everybody, and welcome to Show and Tell. It's me, Lady Ada, Blinka, and Mr. Lady Ada on camera control. Welcome to Show and Tell. This is the best half an hour on the internet. It's definitely the most wholesome. No anti-fans here. Everybody here is positive, building stuff, coding, hacking, showing off. It's just like a wonderful, heartwarming place to be.
Yeah.
Like I said, definitely better than 99%.
It's the safe corner on the internet for now. Yeah. And it's because of all of you. We do this every week, 7:30 p.m. Eastern time. You can get the Show and Tell link in Discord. We post it up right as we go live. You can also watch all the shows on any of the places where we post videos, which is everywhere. And come by, you can show projects, you can show retro stuff, you can show places you've been that have something to do with making something that you want to share with the world. First up, Scott, what you got going on this week?
Hello, I'm trying out a new camera.
Yeah, do you want me to come back to you?
No, I think it's okay. So I got this new. This is kind of like my desk cam, and I thought it would be great because I have a bunch of project stuff here. So the project I'm working on is this. So this is a matrix portal S3 connected to a matrix. But what I've been doing is I've been updating the underlying code that runs on matrix portal, so it works with the ESP IDF 5.1. They did some changes with 5, and they left the old APIs, but they're little less reliable, I would say, than the ones in 4.4. So I'm updating them to the new ones. And so here you can see I've got my test matrix portal animation going. And I just fixed a bug where when you access USB and the flash disappears, it shouldn't crash anymore. Hopefully, knock on wood. Instead, what it'll do is it'll just pause the update while the flash write is going. And the reason that is that when you're writing flash, the PSRAM becomes inaccessible. And so if you have like your big frame buffer for matrix portal or proto matter in the PSRAM, you can't actually access it. So I'd update it if I could, but you probably can't. So I've been working on that.
Okay, cool.
Very cool.
I'm glad people are going to love this because the S3 is a great board. The matrix portal is very popular. S3 is a great board for writing matrices. And of course, we want to update the latest code. We like to skip.
Yeah. And I think S3 is my favorite chip that we support right now. I'm also very excited to get around to adding the BLE support. I'm very excited for that. But yeah, the S3 has been really, really good. It's definitely my favorite of all of them right now. It has everything.
Yeah, dual core, USB, lots of PSRAM. It's one of our new products this week is also an S3.
All right, Wi-Fi and BLE.
Oh my God, it's got everything.
It's a wish list from previous. What do people want in Circuit Python?
Right.
Yeah, remember before there was like we're like, oh, we wish we could do like Circuit Python with native USB, and then it's like, so.
And now we want 2 native USB.
I know.
Yeah, why not?
Never enough.
So
one for host, one for device.
On Fridays, usually you or Tim, who's actually going to be here on the Show and Tell, do deep dive. Is it going to be one of you this week?
I'm hoping to do it, but as folks know, I have a little one in daycare. So thanks to Tim for being my backup, even when I have to switch out kind of late in the game. So
all right. Well, if folks want to learn about the innards of CircuitPython, you can expect some fun on Fridays, whether it be Scott or Tim. Thanks so much for coming by, Scott. Good to see you.
Thanks for having me.
Good to see you, Scott.
All right. Liz has a delightful project. Liz, what's going on?
Well, speaking of the S3, I have a Qualia project. This is one of the bar displays, and it's scrolling some sushis. Right. So this has been kind of a demo that's been getting pretty popular, and basically every... as the sushis advance, a new random sushi appears on the belts, and they scroll along. So I wrote this in Arduino. I set up Platform I/O so that it would compile nice and speedy for the S3. And I have it working on the very narrow yet long bar display. I have a cutie pie here for scale. And then this is the not as long, but still quite nice 320 by 820 display, which if you saw the fireplace project that the Rose brothers worked on, that's actually the case for it, which was very convenient. So I'm working on the project for this now. I'll have UF2s for these so you can drag and drop for quick sushi rolling action. And hopefully there'll also be a nice little enclosure that's also a sushi.
This is a good demo. We were talking about this because I've seen many Japanese makers. They seem to like to have scrolling sushi conveyor belts, and I'm like,
it's a hello world for those type of screens.
Which is I'm like, and I'm kind of super into it. And so you tried this in CircuitPython, but it actually wasn't fast enough, right? So that's why you're doing Arduino.
Yeah, it was a bit slow, and I wanted the art to look really nice because Bruce did a really amazing job. So I was able to get some larger bitmaps with a little bit more higher quality going to Arduino and putting them into memory.
Yeah, I mean, there's both, right? Like if you want fast, quick development, CircuitPython, Arduino a little bit slower, but you'll be able to really squeeze every cycle, every bit. But it looks really good, and it's got that smooth display. Like nice work getting that, no flickering.
Thank you.
I love
Yeah,
it.
it went a lot smoother than I thought it would. So I'm excited.
Okay,
All right.
a
Thanks
big
so much,
success, a sushi success.
All right. Next up, Anne, what you got going on this week? Oh, you're on mute, Anne.
Thank you. I've been doing all these circuit board projects, and this one is a little different in that I've not just got some LEDs on it or touch sensors. I'm actually putting a microcontroller on the back. A little Pico W will be surface mounted on the back of the board. What's it going to do? Well, the theme is rockets, and there's going to be some reverse mount LEDs there, neopixels, so they can be colorful. And it's going to go out and find some JSON and see when a rocket's going to launch, and then alert you to that, which is very handy here, but also for a lot of people who are into space and wanting to know when the launches are going to be. So the thing I ran into is Adafruit has these lovely reverse mount neopixels. I got some from DigiKey because Adafruit had sold out. I relied on the part information, I think, on that was in KiCad. And the problem was, and here's the data sheet, and the footprint was okay. What I did was I added a cutout so it could be reverse mounted. It wasn't there, so I modified the footprint to automatically do that. So it put the 3 holes here all nice and neat, and the board manufacturer likes them. The thing is you can see the pinout, and it turns out I didn't check the schematic symbol, which is separate from the footprint, to this data sheet, which is on the Adafruit website. And it turns out the pin numbering in the schematic symbol was different. So I got these back all nice and neat. I was looking to make them up, and it's a good thing to do some electrical tests and check to make sure things are going in the right place. And it seemed like they weren't. So I got a Metro and checked out the wiring, and the data sheet is spot on. So I've got a Rev B, which puts the pins in the right place. And hopefully in a future show, I'll show you what it actually does.
Yeah, these in progress ones are really neat.
That's how we learn how to be better engineers.
Yeah.
All right, thanks, Anne.
Thanks so much, Anne. All right, next up, JP, what you got going on?
Hey, I got some cool focus stacking and rack focus stuff going on with the Momento camera. So little note about this camera, it has a mechanical focus. So that little tiny lens there has a electromagnetic voice coil that allows it to move a tiny bit. It's probably about, I don't know, 0.5 millimeter or a millimeter. But that's what allows it to focus, that distance between the lens and the sensor there. So you can focus on some really, really close objects, or you can go to what's kind of usually called just infinite focus. So a really neat thing, there's a couple really neat things that you can do since we can program the camera. We can tell it, you know what, don't just like autofocus on the one thing I'm taking a picture of right now. Go ahead and take a picture and then change the focus and take another picture and repeat over and over again. You can do that 30 times, 50 times, 100 times. We've actually got, I think, 256 steps that we can go with our code that Limor put into the PyCamera library. So I have, if you can show the, share the screen there, I have a little sequence here. So this is, I forget how many frames I have in this, about 50 frames. So as I scrub this, you're going to see there's a little bit of flashing as some lighting stuff changes that we're working on locking. But what you'll notice is that the deep focus is what we see right now. So the thing at the far back, the little minifigures. And as I scrub this, we're going to move the guy in the vest into focus, the guy in the red shirt, then the sailor there.
Apple calls this like cinema mode, and you're actually showing how to do this yourself.
Yeah, you can do it yourself. And so this is just a stack of images. I just took quick time to open this sequence and play it. So there's nothing fancy here. So this is really neat for a few cinematic effects, especially if you're doing like animated GIFs and things and videos, to be able to just put one subject into focus and then get your attention on a different subject really economically. This is used a lot in film. Same with another technique that's called a split diopter, which allows us to put two things into focus at the same time that really shouldn't be able to be in focus. And a variation on that is focus stacking, where we say everything in here, I want to get it into focus, even though that's not possible with this camera. But we can do it in software. So I'm going to share a different, I'm going to stop that screen share for a second and start a new one. Let's see. 1 second here. So this is.
Okay, you want me to add it? Or
Yeah, go ahead and add that. So this is everything in focus. So that's a series of about, I think I picked about, again, the 50 photos. And I used some software. I did it in Photoshop, but you can use some command line software. You can use a website online that will take that. And it's actually a really hard problem to solve. And you may just take it for granted, like, yeah, I can see everything. But this is kind of mind-blowing that we can take little slices and bits of all of these 50 images and compose it so that we get full focus of every object in the scene, which is optically not possible, but software lets us do it. So
I think
really
it's like we have a camera that you can program. And the thing is that, like, by the way, this was not something I knew that we could do, but we had the autofocus module. And I was like, well, I think you, JP and I, like, we were chatting. We're like, well, I wonder if we could, like, there's autofocus, but can we manually focus? And I was like, I don't know, but let me, like, look around. I found, like, a random ass Linux driver from, like, some other, like, vision project. And they were like, oh, yeah, here's how you can manually set the voice coil current to change the focus manually. And I was like, neat, let's put it in. And then, it's also cool is you're like, oh, can we update this to do exposure locking? And I'm like, I already added it. Why don't you add that code? So we're actually developing like new camera capabilities on the fly because we can program the whole thing. Whereas like most cameras you get, you're just stuck with whatever the firmware, Canon or Nikon firmware developers came up with. So I think it's kind of neat. It's like we're actually starting to do stuff that most cameras can't do.
Right. Yeah. For sure. It's really fun, really exciting. So
I like this camera because you get to all the features of cameras are in there, but then you discover them. Like they're there, but it's like mathematics. Like are you inventing it or are you just discovering it? And you're discovering it's like, oh, cool. Like this is something that cameras can do, but this is how it actually works. Is it like you really can't mess around with your average camera like this. So it's all open source. So go play around with it. Very cool, GP. Awesome stuff. Are you going to be showing this off on your?
Yes, I'll be showing this and how I put them together and sort of the nitty gritty of it and some theory behind it on the show tomorrow. So come on by and we'll play around with some more cool focus tricks.
Very cool. All right, thanks, JP.
Thank you.
All right, Erin, what you got going on?
Can you hear me?
Yeah.
My computer started playing music, and I'm not sure where it's coming from. So let me see if I can stop that.
I like how it's like, oh, you look like you're in a dance party. I'm going to play dance party.
Well, I am. There we go. Okay, sorry. Too many things open. I was trying to play a song because what I am demonstrating today is these LED lanterns, which are behind me, that are sound reactive, and they're listening to the music that's coming out of my computer, but not to my voice. So I was trying to get some music ups here so I could kind of demonstrate this a little bit here.
Make sure you don't play it too much, otherwise YouTube is going to take us off.
Yeah. But it'll also react to your voice too, if you can hear.
Okay.
As you guys talk. There we go. That might be a better demo.
Hello.
Hi. Woo. Okay, cool.
Yeah, so they have some, it's running on WLED on an ESP32 Feather. And the lights, I'm using a layer on top of WLED called LED Effects. And the LED Effects is it's got like a cord that's running on my computer, and I can hook it up to my computer sound or the microphone or a lot of different types of inputs. And then it runs all kinds of really good sound animation effects. I'm really, I played around with a lot of different sound reactive effects, and I've been pretty unhappy with most of them. But this one seems to be, I don't know, it's got some quality effects that I'm really enjoying playing with.
Oh, well, it looks really good.
Yeah, it does, and it's a cool setup. Each one is on a connector right now, and so it's just modular. And these are just little Chinese lanterns that I got from the Amazon for a big pack of 20 of them for $2 or something like that. So it's a really cool. It's a really cool setup. I want to just kind of see where I can take it and play around with all those sound reactive effects. I've really been enjoying this display as a sound reactive thing. You can mirror it, you can make it go back and forth. It's
not too much. You know what I mean? It's like it's not too much. Like sometimes sound reactive displays, like they take over the room, and you're like, this is
diffused. Yeah, this is really nice. Someone in the chat said close encounters of the Adafruit kind, so I have to do it. Do 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 do. Oh yeah, that's nice. Oh, that's really nice. All right, so Erin, where will this live on the Adafruit Learn world or videos? Where can people learn more about this?
I am just starting this project. I just finished the prototype, so I've got a little bit of writing to do. So probably looking in a couple weeks, it's probably going to be up on the Learn system.
All right, very cool. Thank you so much. This is neat.
Nice work, Erin.
All right, next up, Tim, Foamyguy, star of Deep Dives.
Hello. Good evening.
On this week.
This week I am working on a kind of all-in-one on-the-go text editor. So this is a Feather RP2040 with the USB host, and then plugged into the 3.5-inch featherwing. And then it's loaded up with some code that Jeff started and I've built a little bit on top of. So it's kind of small, but what's on there is a list of all the files that are on my CircuitPy device. And if we click into one, it's going to load up that file for us. And what we have is like a really minimal text editor. This file happened to be empty, so I can like edit it by writing hi show and tell or whatever in here.
A lot of people don't know this, but this is what George R. Martin writes Game of Thrones on.
Mm-hmm. Python of Thrones.
My device is in writable mode right now, so I can actually save it even with Control X. You can switch back and forth between readable and writable mode. So now we edited that file. We could go and see what's inside of it, although I forgot which one it is. The newest thing that I just added to this most recently is the ability to make new files. So Control N from this screen will ask you for a new file name.
Ooh.
We can put showtell.txt or whatever file name we want, and then that will open up an empty file for us to put whatever we want inside of. I'll save this one. So the guide for that is in the works. It's a very basic text editor, but it's really cool that you can do all of this on the go if you have a battery for your Feather. Or you can power it from your PC, however you want. And then all the files are just stored on CircuitPy drive, so you can easily copy those back and forth over to your computer. And then I wanted to leave with one more thing tonight, which I thought was really, really cool that came into the project this week. It was merged in. For the folks that use IDEs like PyCharm and VS Code and stuff like that, we gained CircuitPython stubs a while back. But this week, what we gained is the ability to have board-specific stubs. So usually in the old stubs, the board module, it would just tell you the most basic things like I2C and SPI, and that's pretty much it. But now you can actually set which board you have, and you can have a full list of all of the actual pins. And if you hover on it, it will give you this nice pop-up with loads of details about like what size the NVM is, what board it is, all the built-in modules, all kinds of super cool stuff. So hug report to Justin on GitHub and Discord. He's the one who put the script that puts these sub files together, and that's merged in now. So the next release of CircuitPython stubs will have that, and you can set it up to your own specific devices.
Okay, cool. Yeah, and this will be a guide. I signed this. I sent this to you a couple weeks ago. I was like, hey, try this out, because we had USB host support, and I was like, well, we should do a project with USB host. So yeah, it's a little on-the-go editor, and what's neat is, we might try to get this working on the qualia board that Liz was showing off, so you can have like a really nice big display.
Do round display, maybe e-ink. There's a lot of things that you can do.
Yeah. But we're starting with this because we were like, let's just get something going. And
Yeah,
then,
this is cool.
we have to keep working on USB host. It's a new thing in CircuitPython 9.
Yep, totally.
I like how you built the poster. Like, this is kind of
That's right. This is the poster.
Yeah.
All right. Well, thanks so much, Sam. And maybe we'll see you on Deep Dive. But either way, folks, tune in on Fridays, 3 p.m. Pacific, 5 p.m. Eastern, and you might see Tim or Scott.
Yep.
All right. Thanks so much. Great project.
Thanks,
Yep.
Tim.
Good night. See ya.
All right. Okay.
Let's finish off with some microscopy.
We got to the big. Now let's look at the micro.
Hey everyone.
Hello. What you got this week?
Cool. So we are here again at the 5200. Not much has changed with this microscope, but we are now running our new hardware, which is all in kind of one unit. It was previously, our hardware was this acrylic-based prototype. This is our V0, and I harvested the cable from it right before we started show and tell. So actually during show and tell, I was attaching the cable still. So we're not going to have this fit in the shop much longer. So I figured I'd kind of give you a tour more around the microscope than under the microscope. We still kind of got the same ICE 40 under here right now. So I'm going to take the camera up here.
Okay.
Oh, I think we
So I'll kind of show you how it integrates here. So we have a Windows NT4 computer that the microscope control software usually runs off of.
Perfect.
So we love NT4 so much, right? We can set the high voltage. We can change the beam current from here. So the microscope control computer is still doing a lot. And then we've got our hardware right here. And so we've got two connections to the microscope. This one is the video signal coming from the detector, and this one is what tells the microscope where to put the beam. We've got an amazing old industrial PC here that runs the microscope. This thing has, what is it, I think 15 ISA slots in it or something like that.
Nice.
Redundant power supplies, it's good because they die really frequently. But those power supplies don't die as frequently as the safe power supplies do. So this is the back of the control rack here. We've got a lot of different modules here. So this big focus ion beam was originally an SEM made by Philips called the XL30. And this control console and that base and that chamber were created for the XL30. And then an American company, FEI, so the XL30 is made by Philips actually in the Netherlands. So then FEI came up with the fib column here, and they made their first fib, different model of it, but they had their own chamber and everything. Actually, it was a chamber from an American company. And then so FEI and Philips got together, so they took an FEI fib, they put it on here, they hacked a bunch of racks in, so 4 of these boards are FEI boards, a bunch of these are boards made for TM in the 90s that were then used by the XL30. So this thing's just kind of an interesting example of extensive reuse in corporate microscope development. And then we've got the kind of power supply rack here. This doesn't have very much in it because this fib doesn't do very much. It's only a fib. If it were a dual beam with a fib column and a SEM column, there'd be way more going on here. So yeah, that's kind of the tour around the microscope.
And by the way, where are you?
We are in our new workshop, actually.
Okay, this is your work. I didn't know if you were like at a university or at your own.
No, this is our workshop. I can kind of give you a little tour of that. So we got a 5200 right here. Let me know if you can't hear me anymore. And then we've got a drill 6400 SCM right here. And then we've got a C320F. So this one's bulk field emission. So this one just has a tungsten filament in the top, a little hairpin filament. This one is underrated by somebody started with mine. Underneath here, we've got a
inflated
comically sharp tip we extract electrons from, but they're pretty similar. Yeah, and kind of got the front area up there, over there some other time. And then we kind of got our storage in the back here. And yeah,
well organized.
That's the shop.
That's a really, I was like, this is a very beautiful, well organized, very well lit workshop.
Yeah.
Some people collect, but you collect,
scanning microscopes.
Microscopes
cool.
and family members thereof.
All right, we're starting to develop with them. I'll give you a peek next door. So this building was previously a science museum exhibit manufacturer. So I think like several hundred science museum exhibits were made in here.
Yeah.
The person who owned that has unfortunately passed away. He was, I think, 100, so he was in for a while. So we lease the building now. It's, kind of get to continue what was going on with it.
Yeah.
Get to share the science of these microscopes with everyone and have a good time doing it. So we're hoping to do more live streams. The room I didn't show you up front is actually the studio. So we've got like acoustic dampening and stuff up there. And and we're right here in downtown Portland, just off of Northwest 23rd. So it's kind of a weird area in town for a microscope shop. There's like a lot of retail. There's like crystal healing vendors,
crystal
but
healing.
then you walk by the Mexican restaurant, and then here's the microscope shop. So
That's right.
it's probably kind of a similar experience to what you guys all have in New York. Being in the government district there with electronics manufacturing.
Baker, tidy microscope maker.
Amethyst.
Yeah, very cool. Well,
Exactly.
Guacamole.
It is neat that we're using crystals for almost magical uses.
There's crystals. And
Right.
crystals.
Yeah. There's definitely crystals in this microscope. So.
Yeah.
Lots of
Yeah.
crystals.
All right. Well, thank you so much. Keep coming back. This is one of the show favorites. So folks love seeing all this stuff. So thank you so much for coming by once again.
Thank you.
See you guys again. Of
All right.
course.
I'll see you later.
Keep on scanning.
All right. That's our show this week. Thank you so much, everyone. I really like the microscopes. That was neat to get a tour too.
But it's cool. It's like we haven't seen them in a few years, so it's like great to see. They're still doing it.
All right, so we'll see everybody next week, 7:30 p.m. Eastern time. Come by, show your microscope store, show your sushi conveyor belt, your tiny micro keyboard device, whatever it is. Come on by, your rocket ship PCBs, your DIY photography. Your latest updates with CircuitPython and more, all of that and more
CyberDex
in Show and Tell. We'll see everybody on Ask an Engineer in a few minutes. Thanks so much. Bye.